Hey everyone, and welcome. Have you ever really stopped to wonder what's going on inside the mind of an AI? Behind the curtain? Well, today, we're going to peel back the layers and explore the absolute bedrock principles that allow an AI agent to see, to think, and to act in the world. Let's just dive right in.
This is the big one, right? We see these robots doing incredibly complex things, but how do they actually get from a bunch of code to what looks for all the world like intelligent behavior? That's exactly what we are going to unpack together.
So, here's how we're going to break it down. First, we'll nail down what an AI agent even is. Then, we're going to take a peek inside its quote-unquote digital brain. After that, we'll make things concrete with a delivery robot example, and then explore all the different dials researchers can turn to make these agents smarter.
Okay, first things first. An AI agent is so much more than just a machine running through a pre-written script. It's a total shift in thinking, from telling a program exactly how to do something to just telling it what we want to get done.
So at its most basic level, here's what we're talking about. An agent is just something that can sense its surroundings, we call that its environment, and then make a choice to do something. And the agent, plus that environment it lives in, that makes up its entire world.
And this, right here, is the perfect way to understand the difference. With an old school program, you're giving it a recipe. You spell it out. Do this, then do that, then this. But with an AI agent, you just give it a goal. You say, I want this, and the agent has to figure out the best recipe on its own. It's really the difference between being a line cook and being a creative chef.
So, how does an agent figure out that best recipe? Well, it needs a way to understand its world. It needs a sort of digital brain. So, let's look at what that's made of. You can actually think about this like building a library in the agent's mind. The knowledge, that's all the information in all the books. The representation is the language those books are written in. Let's say it's English. And the entire library itself, the whole collection of everything the agent knows, that's its knowledge base, or KB for short.
Now, this quote right here, it's a huge idea in the history of AI. It's called the Physical Symbol System Hypothesis. And the basic gist is that true intelligence, at its core, is all about manipulating symbols, kind of like doing logic puzzles. Now, this is a really powerful idea, but it's also a bit controversial because it's very different from how we think about modern neural nets, which learn from raw experience, not just formal logic.
Okay, that's probably enough theory for now. Let's make all of this feel a bit more real. For the rest of this explainer, we're going to hang out with a simple little autonomous delivery robot.
All right, so here's the lowdown on our little robot. It has abilities, like moving around and grabbing things. It makes observations using its sensors, like cameras and lasers. It also comes with some prior knowledge already loaded in, like a map of the building. And most importantly, it's driven by goals, things it wants to accomplish, like getting you that coffee and, maybe not getting soaked in the process.
Now we get to the really cool part. How do researchers take a basic robot like this and make it genuinely smart? Well, they don't just sit down and write a billion more lines of code. Instead, they systematically make the robot's world more complicated.
I want you to picture a sound engineer's mixing board, with all those knobs and sliders. AI research kind of works like that. They can turn up the dials on different dimensions of the problem to make it harder, and a lot more like the messy real world. Let's check out some of those dials.
Okay, dial number 1 is all about representation. Now, an agent could try to memorize every single possible state of its world, but that would be insane. It's so much smarter to think in terms of features, like where is the robot? Is it raining outside? Is the robot holding coffee?
And this is where your mind is going to be a little blown. What's so wild about this approach is how powerful it is. With just 30 of those simple yes or no features, an agent can describe and understand over a billion different states of the world. That's how AI tames complexity, not with brute force, but with smart, efficient representations.
All right, so for our next dial, we have to ask, can the agent actually see everything? Is the whole world an open book, or are some things hidden? This is the dimension of observability.
So on one hand, you could have a super simple, fully observable world. A robot knows exactly where everything and everyone is all the time. But in a more realistic, partially observable world, well, it only knows what its sensors can see right now. It might think the coffee is in the kitchen, but it can't be 100% sure until it actually goes and looks. Learning to deal with that uncertainty, that's a huge step up in intelligence.
Another huge factor is time. How far into the future does this agent need to think? The simplest agent might operate in a static world that it assumes will never change. A more advanced agent might plan ahead for, say, the next 10 steps. And the most complex ones? They're designed to run basically forever, constantly planning and adapting to whatever comes next.
And finally, the goals themselves can get way more complicated. Look, it's one thing to have a simple, straightforward goal. Deliver the coffee. Done. But it's a whole other ballgame to handle complex preferences where you have to make trade-offs. Should I take the faster shortcut through the rain or the longer path that keeps me dry? That's not just following orders. That requires actual reasoning.
So this table really just wraps it all up nicely. You can see the whole story of AI research is basically the journey from the left column over to the right, moving from perfectly simple worlds to partially known ones, from actions with predictable outcomes to ones that are random or stochastic, and from being the only agent in the world to having to deal with lots of other agents.
Phew! Okay, we have covered a lot of ground. So let's pull it all back together and figure out what this all means for creating something we can actually call intelligent.
See, the real magic happens when you start turning up all these dials at once. When you design an agent that has to navigate a world that it can only partially see, where its actions have unpredictable results, and its goals are complicated, you force it to behave in a way that's flexible, adaptive, and, well, that starts to look a lot like intelligence.
And if there's one thing you walk away with today, it should be this. Real AI isn't about writing a massive list of if-then-else statements. It's about building a framework, a system of knowledge, goals, and the ability to reason that lets an agent navigate a complex world and make its own smart choices.
And that kind of leaves us with this big, fascinating question to chew on. As we keep turning up these dials of complexity, giving our agents more and more freedom to reason about these uncertain dynamic worlds, at what point does it stop being just a really sophisticated program and start becoming something genuinely intelligent? That's a question I think we'll all be grappling with for a long, long time.